Welcome to the ultra short lecture on BitTorrent. So, BitTorrent is one of the most popular file sharing programs, peer to peer network based file sharing programs as of 2021. And this is based on the familiar technology of DHTs. So, this is an ultra short lecture, but before you go forward, I would request all of you to take a look at the videos for pastry and chord that are a part of this lecture series, because without understanding pastry and chord this lecture will not be comprehensible. So first take a look at that, and we'll only outline few of the basic points, salient features of BitTorrent. The rest will be fairly clear to somebody who understands distributed hash tables. So overview. So as compared to Napster and Nutella, that were typically for smaller files like MP3 files and music files, BitTorrent was made to serve large files or large video files. So the main aim was to distribute large video files. So because of that, it is necessary to kind of re-architect our system. So the user who's sharing the file first creates what is called a torrent descriptor file. The torrent descriptor file has the details of the file, a cryptographic hash of the file's contents. So the cryptographic hash is required for integrity, because since we are talking of a large file and we will discuss how it is actually served, it is possible that some bytes may develop a fault. So because of that, a cryptographic hash is required. So typically the MD5 hash is used for this purpose. And then it is stored and distributed via search engines or via a peer-to-peer system. So the user joins a swarm of hosts. It can simultaneously be a downloader and uploader. So we have been seeing the same format in other P2P systems as well. We have seen the same in Napster, same in Nutella, that the user actually shares a shared directory where you have songs and videos and so on. So since we are talking about large files such as videos, we break a large file into multiple small segments. So each segment is 256 KB, and these are distributed to peers. So these pieces of files are distributed to peers. So this allows the client, the BitTorrent client, to actually download all of these segments in parallel. So this increases the bandwidth and also reduces the time needed to get a file. And furthermore, it increases the robustness of the system. So the peers can themselves redistribute the pieces. So this will further add to the robustness. And pretty much for every file, we will number the segments 1, 2, 3, 4, and so on. And we'll know how many segments there are. So these segments will then come from different parts of the network. So the BitTorrent client, which is a piece of software that every user needs to install, can simultaneously download the different pieces from different hosts. So the key elements in BitTorrent are like this. One is a torrent file, which contains the metadata. Metadata means a description of the file that will be used for searching, and the hash. And then we have a specialized entity called a tracker, which is a server. So this used to be pretty popular in the early days of Bitcoin. So the tracker was coordinating the entire process of downloading a file. This means that the approach would be to connect to the tracker. So the client would connect to the tracker server. This would have a list of peers that contain the different segments. And then the client would connect to the peers to get the different pieces. But now the tracker has gone away mainly because of legal issues. You don't want to have one server which has a list of the entire network, right? So instead of the tracker, this has been replaced by a DHT. And the DHT will help you locate all the peers that contain a given piece using our same DHT mechanism that we have studied in pastry and chord. And the DHT that is used is called the mainline DHT, which basically uses the Kademlia protocol. So recall that in the last few slides of the chord lecture, we did discuss the Kademlia protocol to a certain extent. So downloading and sharing files, well, users need to use regular search mechanisms to find torrents of interest. Similarly, if a server has a new file, It will host it and distribute the torrent file. So it is known as a seeder. So once the client finds the torrent file, it will connect to the tracker or it will use the mainline DHT and will download the pieces in a random order. So there is no fixed order. So you can download piece 3, piece 1, piece 2, piece 4 in any order. So there can be different strategies. So we can prioritize traffic for those nodes that have sent a lot of data on the network. So if let us say that I have been a very active uploader, in the sense I've been very actively supplying my files, I should get some priority while downloading. And also, tit for tat relationships, in the sense if I gave you something, then you will also give me something back with a high priority. And furthermore, I can reserve some bandwidth for myself and have some bandwidth for others. So the main problem actually that happened with Bitcoin is that, again, we go back to college students. So what they were doing is that they were sharing a directory, and the directory used to have these files and their associated torrent files. So all day others were downloading unbeknownst to the sharer. So that was eating up a large part of their bandwidth. And when they wanted to download, they didn't have enough bandwidth. So some of that, so modern clients are configurable. So some bandwidth can be reserved for oneself and some for others. Security and privacy. So as such, BitTorrent does not provide anonymity or security. And furthermore, the onus is on the site that indexes the torrents, like the tracker sites. Even without that, everybody involved in the hosting and propagation of copyrighted or illegal material, in a sense, is legally culpable. So of course, to what extent it is enforced depends on the laws of the specific country. But there are two broad approaches. Either we use a tracker server that provides a directory, or we use a DHT. And then the problem with the DHT is it will require multiple hops, but again, the legal liability is much lower. And furthermore, there is more robustness, as well as it is easy to locate. And given the fact that it will take a proportionally much longer time to download the entire segment, locating a node that has the torrent file will not take that much of time. Plus, these are not strictly real-time tasks, right? So we don't really need to worry about the latency to that extent. So BitTorrent as of today is banned in a lot of places, particularly university campuses, regardless of whatever you are using, tracker or DHT, right? So that needs to be understood. In spite of that, BitTorrent is extremely popular. So the mainline DHT, which BitTorrent uses, is the largest DHT in the world. So it does have somewhere between 10 million to 25 million connected computers. So BitTorrent is clearly the largest file sharing system in the world at the moment. And all the current versions of the BitTorrent clients are compatible with mainline DHT, but they can connect to trackers as well. Furthermore, BitTorrent is expanding, or rather I would say has expanded, and it uses other kinds of protocols. For example, it uses a gossip-based protocol. So basically to synchronize BitTorrent directories, to implement BitTorrent directories among the peer nodes. So this protocol is called Dribbler. So this is again a gossip-based thing where I just maintain a directory of file names and servers, and we periodically exchange and update. So go back to the lecture on epidemic and gossip-based algorithms. So we use anti-entropy to regularly exchange the list of torrents. And furthermore, since there are lots and lots of torrents, the BitTorrent software also gradually learns about the user's preferences and filters the torrents and essentially stores those torrents that are more aligned to the user's viewing preferences. So this, in a nutshell, was BitTorrent. We didn't discuss much about the Kademlia protocol or the mainline DHT. But my feeling was that whatever we discussed towards the end of code is enough to give an introduction to Kademlia. And the protocol, of course, can be read up on the web. But the main idea with BitTorrent should be clear, that it is clearly the largest DHT in the sense that runs in the world. and it uses other methods also. It uses other methods also that include gossip based algorithms and trackers. So the BitTorrent Wikipedia article can give a quick introduction. If you want to know more about BitTorrent, you can always read this paper by Isal Michael et al. And it talks about 5 months in a torrent's lifetime. So it will tell you everything about it. So this lecture pretty much finishes our discussion on DHTs. We have discussed quite a few. We have discussed pastry. We have discussed chord. We have discussed tapestry, cademelia, one slide each. And now we have discussed a system made on a DHT, the mainline DHT, the BitTorrent system. So subsequently, we will move to the second half of the course, right? So the first part was essentially DHTs and epidemic gossip based algorithms and so on. So the second half of the course will basically look at distributed algorithms, and that is important because once we have DHTs are only one kind of a distributed algorithm, but there are many more types and all of them are required. And finally, we'll use the results of parts 1 and 2 to create actual systems. So we did see one actual system. BitTorrent is an actual system, but we will create bigger systems that use the results taught in parts 1 and 2 of this course.